Hello, this is AP Calculus Lecture 5.6a, where we are kind of doing a introduction to differential equations. We'll be on page 363 in the book. So just a definition real quick. Differential equation is an equation containing derivatives. So you're going to have a dy dx or a y prime in the equation. Not all differential equations can be solved. Those that can be solved have infinitely many solutions. Okay, so go ahead and pause the video if you need to. Write these notes down and we'll get into some example problems. Okay, so our first example is going to be just about the simplest one you can get. So let's say we have y prime is equal to e to the x. So you want to rewrite the y prime as dy dx. Now we need to separate the dy and the dx. So let's multiply both sides by dx. So I'd have dy is equal to e to the x dx. This is called separation of variables. Okay, so now we're going to integrate both sides because we want to get an equation in terms of y equals something. Okay, so the antiderivative of dy is just y, and the antiderivative of e to the x dx is just e to the x, and then we would have plus c. So this is what we call the general solution. You went from an equation that has a derivative in it up a level to an equation that is y equals something. Now the constant, there can be infinitely many constants. So that's why we can have infinitely many solutions. Because constant could be 1, it could be negative 100, it could be a billion, whatever it is. Okay, so that is the most basic differential equation that we can solve, starting there. And before we get to some more difficult examples, I want to go ahead and talk about the order of differential equations. Difficult to erase. Okay, so differential equation order. So you need to understand this terminology. So let's say we have this equation like we just had, dy dx is equal to e to the x. We would call this first order because the highest derivative in the equation is a first derivative. So let's give another example. Let's say we had d to the third y over dx cubed plus 2x dy dx minus y squared is equal to sine x. So what order would that be? Okay, that would be third order. The order goes with the highest derivative. So we have a first derivative here, but we have a third derivative here. So we call it by the name we assign the name based on the highest derivative in the equation. Okay, so now the rest of the lecture I'll just work some example problems for you. So we'll clean off the board. Alright, it's going to take a little bit. This marker is being stubborn. All right. It's time for a new rag also. Okay, so hopefully you fast forwarded through that. So now let me give you some examples. So our first example is going to be solve y prime is equal to e to the minus y times sine x. So we want to replace the y prime with dy dx. That's a way of saying the same thing, because it's much easier to separate the variables if we call it dy dx. So is equal to e to the minus y times sine x. Now let's multiply both sides by dx, because I want the dx next to the term that has an x in it. So if we did that, we'd have dy is equal to e to the minus y times sine x dx. Now let's multiply both sides, because I want to eliminate the e to the minus y, the y term on the right side. I want to move it to the left side. So let's multiply both sides by e to the y. So that would be e to the y dy, and then I'll just put this over here, e to the y times e to the minus y would just be 1, right? You would add the exponents. Y plus negative y would be 0, so e to the 0 is 1. So it eliminates the e to the minus y on this side, and we would just have sine x dx. Now we would integrate both sides. E to the y dy is equal to, or the antiderivative e to the y dy is equal to the antiderivative of sine x dx. So we're always going to get to this integrating both sides, and the antiderivative of e to the y is just e to the y. The antiderivative of sine x dx would be minus cosine x plus c. All right, now that is the answer, but most mathematicians want you to indicate this equation in terms of y, not e to the y. So in order to get that y downstairs, we need to take the natural log of both sides. So I would have natural log e to the y. So we're just formatting. This is the solution to the differential equation. We're getting it into a better format. Natural log is equal to the natural log, and we have to put the absolute value of minus cosine x plus c, because you can't take the natural log of a negative, so absolute value of that. Now we can use the properties of logs to bring that y out front. Y natural log of e is equal to the natural log of the absolute value of minus cosine x plus c. And then the natural log of e is 1. So we have y is equal to the natural log of the absolute value of minus cosine x plus c. So now we are in the format of y is equal to something, and mathematicians prefer you to write it that way if you can. Okay, so this is what we want to get to. This test on this section is a multiple choice test. So one of the answers would be this. If this is one of the answers, then you could just circle that as the correct answer. But probably I would make you get down to this format. All right, I definitely wouldn't have both as a correct answer. All right. Let's do another example. Let's look at example 4 on page 363. So this is an example you really need to pay attention to. So it says we have y prime is equal to x times 1 plus y. So I'm going to rewrite y prime as dy dx times 1 plus y. Let's multiply both sides by dx you'd have dy is equal to x times 1 plus y dx. Now on your homework you don't have to write that. You can just go straight from here to here. I'm just doing that for illustrative purposes. Now we want to divide both sides by 1 plus y. Now, instead of distributing the x and having the xy, that makes everything more complicated. I think it's less complicated if you just pull that the 1 plus y, keep the 1 with the y there, and then you've got an easier antiderivative to take. So now we have separated the variables. So we're going to integrate both sides. So if you remember from the previous section, in the 5.1 through 5.4, we did this kind of integral. And then the antiderivative of dy over 1 plus y is going to be, it's a simple one, you don't even really need to do a u substitution. It would be the natural log of the absolute value of 1 plus y is equal to 1/2 x squared plus c. Okay, this is still, it's not in terms of y. So we have to get rid of that natural log. So in order to get it in terms of y, what we want to do is exponentiate both sides. Well, what does that mean? That means we raise e to the power, e to the natural log of 1 plus y. We can go ahead and move that from absolute value to parentheses there because it is going to be positive, is equal to e to the 1/2 x squared plus c. So that c is also in as an exponent. So now the e and the natural log cancel, and you have 1 plus y is equal to e to the 1/2 x squared plus c. Now we're almost home. This is the same. We can rewrite the expression on the right side of the equal sign as e to the 1/2 x squared times e to the c. Because when you have addition of exponents, that's the same as multiplying the same base to the exponent. And e to the c is just a constant. We can write that as c. It's just going to be a number. E to the c is e to the any number, so we can just call that c. So then we would have 1 plus y is equal to c. I'm going to bring that e to the c out front as c, e to the 1/2 x squared. And then finally, solving for y, would have y equals ce to the 1/2 x squared minus 1. So that is the best formatting, and mathematicians are going to make you get to that. All right. So that would be the form of the answer that would be on the multiple choice test. All right, make you go through the exponentiation part to get that C out in front of the E term like that. So that minus 1 is not part of the exponent. It's just that whole thing, minus 1. All right, let me give you one more example. And then we will be done with this video. All right, so this example is y prime is equal to 3x over 5y plus 1. So the first thing to do is write y prime is dy over dx. Now this is pretty easy to separate the variables. We could just cross multiply. Bring the 5y plus 1 up here, multiplied by the dy, and the dx times the 3x, and you would have 5y plus 1, all multiplied by dy, is equal to 3x dx. So now we have separated variables. And sometimes it can be a lot of work algebraically to separate the variables. You will have one like that on your homework, number 6, which we'll talk about. Now after we've separated the variables, let's integrate both sides. So this would be 5/2 y squared plus y, right? And let's double check that. 2 times 5/2 would be 5 times y. So the antiderivative of 1 is not 0, it's y. Be careful there. And we would have equals 3/2 x squared plus c. Now, believe it or not, mathematicians are okay if you don't solve this for y. They're okay if you leave this alone like this. So for this particular problem, the multiple choice answer would look something like this. All right, so the homework is on page 363. It's 1, 2, 3, 5, and 6. Now, of these, the separation of the variables is not too bad, except number 6 is a little tricky. So a hint for number 6, a hint would be somewhere along the way you're going to need to factor out an x. So factor out an x. So somewhere along the way you're going to need to do that, and then you can separate the variables. So see if you can get that, and I will talk to you on the next one.